This is going to be the second session in the SSL certificate series of sessions. In this session, we'll be discussing mostly about the OpenSSL. We'll be doing some hands-on and more about it. I'll quickly jump into the agenda. So here is the agenda. We'll be discussing what we understood from the previous session. Moving on, we will look into installing the OpenSSL onto different operating systems, Windows, Linux, and Mac. We will learn about the key entities and how they are related to each other. Then, what are the different file extensions? And there are two things. One is we can have self-signed certificates as well as CA signed certificates. So, what are the steps involved in both cases? And finally, we will, summarize this session and we'll discuss quickly about what is the next session that we are coming up with. So, setting some background here, some context setting I'm doing. In the last session, we discussed about SSL. What is SSL? A secure socket layer. It's deprecated. There were two versions, SSL 2.0 and 3.0. There are known vulnerabilities because of which this SSL is now completely deprecated. Very legacy and very old systems might still be using it, but it is always recommended that we move to the latest one, which is the TLS. TLS stands for Transport Layer Security. It is the most secure and active protocol, so as to say. It has got strong encryption and also it supports the PFS, right? So perfect forward secrecy that we discussed in the last session. Also, it is a common implementation for HTTPS and APIs these days. So TLS, what is TLS is nothing but a modern and secure protocol built on top of SSL by fixing its flaws, right? So that's how TLS is. We are having OpenSSL, which is a command line toolkit that lets you create keys, CSRs, certificate signing requests, certificates, and it is widely used in servers, dev setups, testing, etc. This toolkit is available for like Windows, Mac, and Linux as well. We will discuss quickly about the OpenSSL installation. So by default, it is not the case that OpenSSL is always available. It is not pre-installed. Either we will have to install it, or in some cases we will have to upgrade the OpenSSL. For Windows, we will have to visit this website in order to download the binaries, the compiled binaries. And once we install that, we have to set the path environment variable. So something like this, in the path environment variable, you will have to point to the OpenSSL bin folder. For macOS, you will have to go for brew install OpenSSL and it requires homebrew. For Linux, like Ubuntu and Debian, we can use the sudo apt update and sudo apt install OpenSSL command. Once the installation is done, you can confirm the OpenSSL version by using OpenSSL version command. I have taken a screenshot here just to understand how the output looks like. So it confirms the OpenSSL version. If you can see this version, that means the OpenSSL is successfully installed on the system. Now let's move on to a very key topic. What are the key entities that are involved in setting up the certificates, right? So first thing is private keys. What are private keys? They are the unique secret and provides the uniqueness, that is the identity of a particular sys component, right? So similarly, there is public key as well. Public keys are not separately created by default. They are part of either the private key or the CSR or the certificate, right? So we'll discuss more about it when it comes in the next slides. CSR is certificate signing request, right? So it is basically a file with individual identity and the public key, right? So we discussed that this one is embedded. So public keys are embedded in private key as well as they are embedded in the CSR, certificate signing request. So certificate signing request is like a file where we put a request with all the details about our particular entity and we submit that file to an authority. So that what is that authority? That is called as CA, certificate authority. Some of the examples are DigiCert, Let's Encrypt, GoDaddy, etc. are the certificate authorities, that is trusted third parties that vouch for identity. Next comes the certificate itself. So as you can see, certificate is a combination of the public key, the identity, and the CA signature. So now you can relate these three things, right? So the certificate is basically the public key that we discussed here, the CSR, which is the identity, and the CS signature, right, is the certificate authority signature. When these three things are combined, we get a certificate out of it. There are things like certificate chain as well. So in what is a certificate chain? It's basically a trust chain involving root certificate, intermediate certificate, and a leaf certificate, right? So that is called as a certificate chain. Here is a simple analogy to understand the things better. So we discussed about these six entities. So what is a private key? It stays in our pocket, right? It has to be kept very secret. It has to be restricted when it comes to accessing the private keys. CSR, certificate signing request. It is like the passport application, right? So when we want a passport, we fill up a form, we provide all our details, and we submit it to the government authorities, who then give us a certificate, who then give us a valid passport with us, right? So that is the CSR, the form that we basically submit. Certificate is the passport issued by an authority, right? So which is the authority we discussed? It is the certificate authority. Browser servers only trust passports signed by well-known authorities, right? So, what are those well-known authorities? Is the authorities like DigiCert and Let's Encrypt or GoDaddy. Okay, so this is a very important concept. Make sure you understand this well. How are the entities related? Now, this is also an important topic. So, first we create a private key, right? A unique identity we create first. Then we create a certificate signing request. Okay, so there are some commands. We will be discussing about those commands using which we create all this. So the first step is to create a private key. Second step, to create a certificate signing request. As discussed, both of them, private keys and the certificate signing request, public key is embedded in both of them. We then hand it over, like this combination, we hand it over to a certificate authority, right? The certificate authority, what it does is, on behalf of the information that we provide as part of the CSR and as part of the private key, it then gives us a certificate which can be utilized, okay? So, and this is the most important thing, which is the output of the entire process, the certificate itself. Now, where all we have to use it, right? So, where to use this certificate? So, the usage differs on the use case, like what is the scenario that you are trying to do. If it is a normal HTTPS, like one-way handshake or one-way TLS setup, then only on the server side we have to install the certificate, because clients, mostly the browsers, they already trust the certificate authority. So if the server is having the certificate installed, and if a request is going from a browser hitting to the server, then whatever certificate the server returns in response, the browser will check that certificate with the certificate authority it trusts, and it should cross verify, it should validate, based on which this one-way setup will be all fine. If it is a mutual handshake, like two-way handshake it has to be, then in that case the certificate has to be installed on both sides, server side as well as client side. On the server side, we have to install the certificate, plus we will also have to do certain configurations in order to validate the client certificate as well, because it has to be two-way handshake. On the client side, though, we will be having its own certificate, plus we also need to have a key issued by the CA that the server trusts. Okay, this is how the two-way handshake is set up. Okay, so now you understand how the certificate has to be installed on what sides. Moving on, let's quickly discuss about what are the different file extensions. Now, this is a huge list. It can be a bit complex to understand, but with practice, we learn it better. So first comes the private keys. Private keys, as we know, the file extensions can be .key, .pem, .p12, and .jks. Now, some of these file extensions might repeat in the rest of the presentation as well, but it is because the private keys are also embedded in those file formats. Okay, so let's see what is next. Next is a public key. We discussed about it. Public keys usually are not separately created, but they are embedded inside the private key, inside the CSR, as well as inside the certificates. Next one is the certificate itself. Now, certificates are either .cert, .cer, .pem, or .der. Okay, so first two are very clear, cert and CER. But what is next? .pem and .der. So here is the difference. .pem versus .der. Both of them contain the same information. It's just that .pem is a textual representation of the private key as well as the certificate, whereas .der is the binary representation of the same information, right? So it also, the .der also contains the private key as well as the certificate. Okay, what's next? Certificate and the key. Now, we discussed, right? So this extension you can see getting repeated, PEM here as well, and here also now it is coming as PEM. So it is because in the PEM file, there are multiple blocks in the file itself, which you can see the private key is also covered there. Okay. Also, there are two more extensions, .p12 and .pfx. Now, specialty about .p12 and pfx is they are password protected. They also contain the certificate and the key, but this time the difference is these two files are usually password protected. P12 and PFX, they are PKCS12 format, and they contain both the certificate as well as private key. Now, chain of trust. We on the last slide we touched on this. Chain of trust is usually a series of certificates like certificate authority, intermediate certificate, and the leaf certificate, often bundled as a .ca bundle, P7b, or .pem file. P7b is PKCS7, that is particularly cert only. No private key is usually there in this kind of certificates. Finally, the requests or packaging. So we discussed about the CSR, right? So certificate signing request. This is another file extension. They are usually .csr files. The use of that CSR files is CAs use these CSR files and they return with the cert or CER or PEM files. Hope this is clear. All these are the file extensions that we will be discussing. Majority of the cases you will have to deal with .key, .crt or .cer, .csr. These are the common ones. Nowadays we can also be able to see .pem, .p12, .pfx. These are also quite frequently used. Now, the next step is actually doing the hands-on. So we'll be now looking into some of the OpenSSL commands which help us, create the private keys, create the CSR, and create the certificate out of it. Now, when it comes to creating the ultimate certificate, there are two ways we discussed about this. Either the certificate can be self-signed or it can be CA signed, certificate authority signed. The first half of the hands-on is going to be self-signed certificates. You can look at the title, and as per that, we should be able to follow the next session. So here is the command to create the private key, right? The first command, OpenSSL gen RSA out server.key and 2048. So this is the syntax to create a private key. Here the name that I have given to the private key I wanted to create is server.key. The name can be anything, but the syntax remains the same. Here is the second command. As the name indicates, it is for certificate signing request. Now this is the command. It is like we are filling up the form for getting the passport for ourselves, right? So using this command, once we give this command, it will ask a series of questions. Those questions are covered in the next slides. But you will see a series of questions being asked, and we have to answer them so that we create this signing request for the certificate authority. The command syntax is OpenSSL request new key. This is the key that we created here as an output here. We are passing that key here as an input, and we are here creating an output as a CSR, certificate signing request file. The name of the file that I have given is server.csr. Now the third one, because we are talking about self-signed certificates, this is the command using which we ourselves are signing this CSR. Okay, so if you can look at the command, look at the red color that I have highlighted here. What we are passing here is the CSR file as an input. That is the certificate signing request that we created here. We are passing that as an input here. The sign key that we are passing is the server key that we created in the first command. And as an output, what we are expecting here is the server.crt file, that is the certificate file. And one more important point here we are giving -days 365, which means the certificate that we will be creating, we want that certificate to be valid for a year, 365 days, right? Now, last one, once the certificate is created in the third step, in the third command, how to verify the certificate, whether it is valid, what is the validity, and things like that, right? So this is the command OpenSSL x509 -in. Now this time, as an input, we are giving the certificate server.cert that we created in the third step, and we want the output as a text, right? So yeah, this is the command. Now, as part of these top three commands, right? So number one, number two, and number three, which is to create the private key, CSR, and sign certificate. As part of an output of these three commands, these are the three files that got created. You can see server.key, server.csr, and server.cert, CRT file, right? So hope you are following till now. Now let's look into the actual output of these commands. Now you will see the yellow highlighted same commands I have highlighted here. The first one was to create a server.key. It doesn't give us an output, but it creates the file. This is the second command, OpenSSL request new key server.key, and the output is CSR. Now, if you remember, while creating the server signing request, I mentioned that it will ask you few questions, and all the underlying things are the questions that it has asked me. So here also it gives a clear textual output. You are about to be asked to enter information that will be incorporated into your certificate request. Okay. Now, what all things it asks? It asks for the country code. It has to be a two character country code, like I have given in for India. State or province, I have given Maharashtra. Locality name, usually it is a city. I have given Pune. Likewise, organization name, some dummy organization name I have given. Organization unit, I have given that as DevOps. Common name, I have given as my org common name, CN. And email address, I have given vaibhav@myorg.com, right? So all the below questions, like it also asks for a password, it also asks for an optional company name, but that is all optional. We can skip that as well just by pressing the enter key. And then this is the third command, right? So OpenSSL x509. Now this command is, you can see the out part here, right? So what what we are here doing is I'm writing here as an output. I want to create a certificate itself and validity for 365 days. Now, as soon as I enter this command, it returns saying certificate request self signature OK, and then it gives the subject as all the information that I have inputted in the previous command, right, for all the questions that I answered. And the last command, if you remember, was for verification. So this is the command OpenSSL x509 in server.crt text and no output. There, when we enter this command, whatever CRT file that we created in this step here gets validated and it gives a textual output of the entire file. Here you can see because it was created for 365 days, you can see it got validity from 6th of September 2025 up until 6th of September 2026. Exactly 1 year validity this certificate has, right? Apart from that, the file also has the public key. The file also has the, the issuer details and all. Because in this case, it is a self-signed certificate. It is very important to understand because this is a self-signed certificate. Here, the issuer and issued to will remain the same. It will be the same entity for, in this case, it will be the my org CN. Okay. Now, how the certificate looks like. This is how the certificate looks like. I've taken a screenshot of these two tabs, general tab and the detail tab. So the first tab says you can see the text here that I'm highlighting, right? So this CA root certificate is not trusted. Why it is saying so? Because it is self-signed. Okay, first thing. And further details it shows as issued to my org CN, issued by my org CN. This confirms that it is a self-signed certificate because the issued to and issued by both are same. It also shows validity. You can also see this exactly 1 year validity period is there. If I go to the detail tab, there you can see issuer is vaibhav@myorg.com. And if I click on the subject, which is, if we can see like half line here, if I click on that, here also I can see the email as vaibhav@myorg.com, again because it is a self-signed certificate. Hope you understand all this. Let's move on to the next one, which is the second part of it now. So here again, we are talking about certificates, but we are talking about self-signed certificates in this case. Okay, sorry, CA signed certificates in this case, right? So in the first part of the hands-on, we talked about self-signed certificates. Now whatever we will be looking at or learning, that will be all CA signed certificate. Uh, First two commands remain the same, there is no difference. That is creating the server key, creating the CSR still remains the same. But here the additional step that we do is we also create a certificate authority. Okay, what are the commands then? So I've given number 3 here because number 1 and number 2 remain the same as we discussed. So what is the number 3 here? It is creating a root key and a certificate for the certificate authority itself. So you can see the two commands are there: OpenSSL genRSA out myca.key, and 4096 is a code that we give. And the second command says OpenSSL request x509 minus new hyphen nodes hyphen key. Now we pass this key myca.key, and apart from that, few more keywords we have to supply. SHA-256 days 1024. So this time we have increased the number of days, and this time the output is a PEM file, myca.pem. Okay, so this PEM file we discussed on the slides earlier. It is a combination of the private key as well as the the certificate itself. Okay, so this PEM file now this time represents this certificate authority. Okay, very important. Now let's move on to the next step, which is issue server certificate signed by above CA. Now here comes the difference, right? So in the second command, which is not on the screen right now, but we discussed about it in the previous slides. In the second command, if you remember, we created a server.csr file, right? Now we are using the same file here. So OpenSSL x509 request in, what is the input? The server.csr file. This time we are passing two more additional things. Certificate authority -ca. We are passing that as myca.pem, which is the output of this command. CA key, which is the myca key, and then CA create serial, and output that we are expecting is server.crt, again with a validity of 365 days and SHA 256. Don't get confused between these days and these days. this is the validity for the root CA, that is the certificate authority, and this is the validity for the actual certificate that we will be using, we will be installing on the certificate, sorry, on the server. Okay. Um, and again, the same command, right? So for verifying, it is the same command, OpenSSL x509 minus in, this is the server.crt file, text output. And in this screenshot, you will see I've highlighted these four files, right? So the first two files remain the same because the commands doesn't change for them. Server.key and server.c are still the same. What this time is new is my CA key, my CA PEM, my CA SRL. Now this SRL is created as an output of this command. Okay. And then the last one is the certificate itself, which is created by the fourth step, right? And you will see, the time is very latest one. Okay, hope you are following this. Next comes similar screenshots. So OpenSSL. Now these are the screenshots only for the certificate authority for the commands that we saw on the earlier slide. So yeah, the same CA key. Then in the next one, uh, this time it doesn't ask for too many questions, though there are still some questions like it asks for country name, state and province, locality, organization name, organization unit, common name, email address, and things like that. But this times the password and all those things are not being asked. It then, creates the CAPEM file for us, my CAPEM file for us. And then we are using this in the third command to create the certificate itself. Okay. I hope this is being followed. Now this is very important. You can see the clear difference here between the self-signed certificate and the CA signed certificate. If you now verify the certificate using the last command, you can see this time the issuer is my CA org and subject is my org. Okay, so this time because we involved the certificate authority, it clearly says who has issued the certificate to whom. Okay, in the next screenshot, it will be very clear. See this green highlighted, issued by my CA org CN, issued to my org CN. Okay, so this time also this message is different. Windows does not have enough information to verify this certificate. It is not saying that it cannot be trusted because the certificate authority has this time, approved it, authorized it. But because the certificate authority is not well known, we created it ourselves. That's why Windows does not have that information. That is why this message is coming. Again, the validity is for 1 year. Here, there is the clear difference that you can see. The issuer is the CA, my CA org CN, but issued to, that is the subject, is my detail, right? The CSR which I created myself. Hope this is very clear. We are finally on this last slide. I'll wrap it up quickly. So what we learned about this entire certificate hands-on, these are the things we discussed. What is SSL, TLS, how to install OpenSSL, what are the important entities that are involved, how they are related, what are the different file extensions, and then finally we concluded with some hands-on how to create a self-signed certificate, how to create a CA, and then a CA signed certificate. We discussed about it. In the next session, I will be actually utilizing these certificates. Okay, so I'll be putting the certificates to work where we will be having some, I'll try to get a Java microservice and if possible also an Angular or some kind of an UI where we will be able to see with certificate and without certificate what is the difference, right? So yeah, I hope this helped you to learn about these things. I'm also learning, so please help me improve. Share your feedback in the comments, and thanks a lot for your time. Thank you.